Yes? No?
Yeah, we can see it.
Okay, so we're going to eventually get to question 13 in section 2. You can tell me if it's that 13, because I think there's another one that has a 13 as well. Is it this one?
Yes,
Are they-
this one.
Okay, so I'll just take a note of that and we'll move over to the other screen where we can do the answers. Is that focused right, or is that just my eyesight? Is that focused okay, guys?
It looks all right to me.
It's probably my eyesight. Okay, so we are being asked to find T3 of x, and we're being asked to do a function which is essentially x e to the x centered at 0. So you could say it's Maclaurin series, but that's just a special case of a Taylor series. Now, T3 of x, if you want to write it out in full, is the value of the function at 0, the derivative of the function at 0, technically x minus a, but since that's 0, it's just going to be x over 1 factorial, the second derivative at 0, x squared over 2 factorial, and lastly, the third derivative at 0, x cubed over 3 factorial. And I know to stop at the third derivative because of the T3. Now, there's a fair old chance that quite a lot of these will be 0, and that's okay if they are. So I'm going to do kind of the working over here, and then as I find values, I'll put them in here. So there's our original function. The value of the function at 0 is 0 times e to the 0, which is 0. So there we go. The first derivative is going to be a product rule. So it's going to be f dash g plus f of g dashed. So that's 1 e to the x plus x times, and if you differentiate that, you get e to the x. And I'm going to call it 1 plus x e to the x by bringing out a common factor. And now I can get the first derivative at 0, which is 1 plus 0 e to the 0, which is 1. So that guy's 1 x over 1 factor. And then I can now do a second derivative using yet another product rule. Well, differentiate that, you get 1, leave that alone, plus leave f alone, differentiate e to the x. That eventually gets you that. Now you can find the second derivative at 0, which ends up being 2. So this guy's going to be 2x squared over 2 factorial. And now we can move on to the third derivative. And it's going to be yet again another product rule. Differentiate this, you get 1 e to the x. Leave that guy alone. Differentiate the g, which is again e to the x. And after a little bit of work, you can tidy it up to look like that. And then evaluate the third derivative at 0, and that ends up being 3. So far, so good. First, second, third derivative evaluated at 0. Here, here, and here. All I'm going to do now is tidy it up. 1 factorial is 1, 1, 1, you just get x. 2 factorial is 2, 2 over 2 cancels, you just get x squared. 3 factorial is 6, 3 and 6 get you a half. So you get that. And that's 13a done. Now, 13b, which is pretty common with these questions, is that we're going to find an expression for what's sometimes called the remainder function. as another name, error function. It's essentially the absolute value, because you want the answer to be positive, of the real value of the function, take away, in this case, t3 of x. So that would be the remainder function when you're using t3. F of x is this guy, take away that guy. And to make it look a little bit prettier, and we have calculated or found an expression for the remainder function. Now 13c says find the maximum error. That really becomes the largest value of this function when you use x in the range -0.2 to +0.2. And we do it essentially by using calculators, or as I'm about to do once I load it up, because I had to close everything down to get my mic, I'll use Desmos. Okay, so swing over to Desmos, and we will try and evaluate that remainder function at, oops, it didn't load up the way it should have. There we go. We'll try and get that guy sorted out. So the function that we're talking about is essentially, oh, I can do it this way, can't I? This is a notation. Little curly bracket, x e to the power of x, take away an x, take away an x squared, and take away a half x cubed. Now, I'm not looking at what I'm typing, so I hope it looks good. It does. And then I believe you, if I get the notation right, you do a colon, and then you can do -0.2 less than x less than 0.2. And then you finish with little curly brackets. I think you do. Right, draw. Oh, it's not it. Oh well. Plan B. Not quite as pretty, but x, put a y equals, which is the remainder function. There we go. I'm only interested in x equals -0.2. And where's the other one? I guess I can put an enter here and do x equals 0.2. That'll work. If I go over here, I should be able to change the x value. And basically just trying to get a window that I can work with. So there's -0.2, and at this extreme, I have a 0.2. And the y values are going to be tiny. So I'm going to try -0.1 to +0.1. Still no good. Okay, how about 0, 0? I've got another plan if this one doesn't work. We're getting there. Right. At this extreme, the error at that point is, what was that? 0. I'll just write it down. 0.0002538. And if you go to this side, you get the error of 0.000286. Right, one of those numbers is going to be the guy we're looking for. So let's show you. The worst, oops, try again, come on computer, there we go. The worst case scenario is that number there. Between the two, it's larger. So that's 0.000, I'll round it off to 3. So what we are saying is that if you want to do an estimate of this function, you can use this polynomial. And as long as you keep x's within this range, we can guarantee that your answer will be pretty close. It will be close, give or take 0.0003. Right, so first 3 decimal places are good. And that is it. Now, there is other plans that I could have done. I could have evaluated the remainder function at only those 2 endpoints, and I would have got those 2 numbers. And the reason I know that is, have you noticed the error function? You always get the worst error at the ends, right? At the start and finish. So you could have gone up with the same result that way. Yeah. Hopefully that's what you were looking for, whoever asked.
Yeah, thank you. I was just confused about like the last part, so that cleared up it. Thanks.
Okay. Playing about with my thing, I must have banged it. Just looks wrong. It's kind of looking off today for some reason. Right. Next question. Next topic.
Could you do question 20 of section 1?
Sure. I'm saying that as if I know what that is. So let me check it. Section 1's a multiple choice, and question 20. Is it the one that looks like this? You have a multivariable function that looks like that. Is that the one?
Yes, I think they are asking for finding the limit.
In this case, they're asking to find the domain.
Domain? Okay.
Right. So the domain is going to be, in English at least, usable values of x and y. So we are going to set using interval notation. What does that look like? Right. I have a fraction. Fractions are okay unless the bottom is 0. Great. So I'm just going to focus on that guy. Now, secondly, since it's inside the square root, I need to have that. Agreed? Whatever is inside the square root has to be greater than or is equal to 0. But because I don't want the bottom to be 0, it means that I'm not allowed the 0. I'm allowed that. And so our domain is that one, which is B. So as long as the relationship is the x squared minus y squared is a positive number, you will be able to get the answer to this. And that's essentially what the domain is, right? The values of x and y that give you usable pairs of values, x and y.
I also have another question. So I believe that number 31 has a typo on the question and the key.
Oh, it could have. Which question again?
Number 31 of the section 2.
Okay, so it's very possible. It's a lot of questions. Surprised I haven't made more typos. Let's get into it. 31. Okay, so A of t is something, V of 0 is 1, 2, 3, and R of 0 is 0, 1, -1. Find V of t and find R of t. Is that the question? I'll show you. Maybe it's easier if you see it. Is this the question 31 that you're talking about?
Yes, I believe that the answer has the typo.
Oh,
With
the
the-
answer has a typo. Oh, that's possible. So, whoa, have to scroll. Oh, okay, do it slowly. Evidently, well, maybe that's clicking. Still a little bit to go. Why can't I just pick this and drag it down? You would think I should be able to. This better be worth it. Okay. So here is the solution to the velocity first. So
So,
where's the
that-
typo?
The typo is in the z factor. It should be 3e to 2t. It is,
Oh, 8 now. Is
It
that
is
what you're
8.
saying?
yes, it is 8 to the 2t in the answer, which make me wonder.
The original you're saying didn't have 8, it had 3.
Yes,
Is that, yeah, okay.
it kind of altered the,
Oh, it
solution.
will, it will. So the best thing to do is pretend that the original had the same number as the solution. That way they match. It's much easier to do it that way than if you tried it to make it work the other way. I've lost the question. Which question was it again?
31.
Okay, I went too far the other way. Yeah, so pretend that said 8 and everything is good.
So I just pretend it is 8, right?
That's, I mean, if you did the question with 3, you would have a different answer because it's a 3. But my solution is using 8, so I think it's easier if you just pretend the question had 8 all along, in which case they match now. So what's our next question?
In section 1, I had some of the multiple choice questions.
Mm-hmm.
And I wanted to look at 3.
Let's see what 3 has. Almost there. There we go. So we have a sequence, not a series. So that makes a difference. And the sequence is 1 take away the sine of 1 over n squared all over 1 over n squared. And then it gives us a choice of 4 things. 3 of them converge to a number, either 0, 1, or -1. And the last choice says that it diverges. So we need to go,
I think I was thinking of it as a series.
then that would make a big difference. If you notice it is a sequence, might as well finish it now that we've started it, showing what it would look like. What you have to do is simply, if that's the right description, you have to find that limit. So in our case, it's going to be the limit as n tends to infinity of a really, really ugly fraction, right? And you should check very carefully that it is possible to use L'Hopital's rule, because it looks like it should be a L'Hopital's rule, agreed? But let's brute force it and find out.
What I did was
Mhm.
I just put a parentheses around the numerator and pulled the denominator up, flipped it, and multiplied it.
No, nothing wrong with that. That works. 1 over infinity squared is 0. Sine of 0 0. So you have 1 take away 0. 1 over infinity squared is 0. 1 over 0 is not indeterminate form. This thing diverges. And why do I know it diverges? Because any number over 0 becomes infinitely big, doesn't it? It diverges. Now, if it had been that guy, okay, could happen. If it had been that guy, cosine of 0 is 1. 1 take away 1 is 0 on the top. 1 over infinity squared is 0 on the bottom. So that could have been done using L'Hopital. If you ended up doing L'Hopital, and you're just going to trust me on this, you end up with positive the sine of 1 over n squared. And you might think, well, what happened to this guy and this guy? Well, when you do a chain rule and this guy, they actually cancel each other out. So all you get is that, and that gets you the sine of 1 over infinity, which is the sine of 0. So this one would have a limit of 0. So changing the sine into a cosine does make a huge difference to the final outcome, even although the sine and the cosine, if you think about it, aren't that different from each other, right? They just cycle slightly out of phase. That phase difference is enough to make a difference. Next question.
Could you also look at 4 again?
Sure. Now, question 4 is based on not any kind of real test, but the idea that intuition is to come into play, right? Mathematical common sense. We are told that every term in this series is positive. We're also told that that series converges. And then we're given 4 choices, only one of which is false. So let's go through each one. That one is guaranteed to converge. I could argue something like this. En is guaranteed to be bigger than that guy. Agreed? And this converges. So wouldn't it make sense that something that's smaller than that has to converge, right? Because it's going to be made up of smaller bits and they're going to converge. So off my list. Sigma En squared also converges. A little bit harder to argue this one, but I think the logic still works. En squared is going to be smaller than En. Now, when En is a number like 3 and 5, that's not true. But since this converges, doesn't there come a point in time when these numbers are definitely less than 1 and getting really, really small? I mean, that's the only way you could converge. So if you square a very small number, doesn't it become even smaller? And I am smaller than somebody that converges. That's the argument for why that one converges. Now, the next one is that one. But let me go straight to the diverger, because this one is a little bit problematic. Isn't En really, really small if it converges? What does 1 over En become? Really, really big. And so it diverges. Well, you could look at this. Won't the limit as n tends to infinity of this guy have to be 0 if it's going to converge? So what would the limit of n tends to infinity of 1 over that be? Well, it'd be 1 over 0, it'd be infinite. So these terms have to get infinitely large, and adding up infinitely large makes it diverge. Is that a reasonable argument that you're comfortable with? Now, this one, being the only one that's left, must be the only one that's false, because the other 3 say that. But I could give you an example. Would you all agree that that converges? If I take the square root of this, don't you get that one? Haven't I found what's called a counterexample? Which basically says, if you can find one example where whatever the statement is doesn't hold, then you've proved that that statement, that general statement, is false. Now, it might be true sometimes, but it's false as this always happens, because you found a situation where it didn't. And that's kind of the logic I'm using there. So there are no calculations or tests, really. I'm just thinking, what do series that converge do? And how would another series like it fit into that situation? Would it also converge because of what, the logic of the situation? Okay, where are we off to next?
I was wondering if you can do number 15 on the multiple choice.
Sure. This is finding the angle between 2 vectors. We're going to use the dot product for that. The first vector is u -1, 1. The second vector is 1, 1, 0. And I'm going to use the dot product, which in this case is 0 times 1 plus -1 times 1 plus 1 times 0, which comes out nice and conveniently to be -1. I'm also going to find the magnitude of u, which in this case ends up being the square root of 2, and the magnitude of v, which if you go through it is 1 squared plus 1 squared, gets you square root of 2. And we have a formula for finding the angle between 2 vectors. It says that the cosine of that angle is the dot product of the 2 divided by the magnitude of the 2 vectors. And so -1 over square root of 2 times square root of 2, which ends up being -1/2. And the inverse cosine of -1/2, at least in degrees, although I could have got it with my unit circle, I'm just going to do it this way, is I don't like that number, but it's right. Which makes it D. That's not right.
On the answer sheet, I think
I
it's,
didn't put -1/2. That's why.
oh, yeah.
Let's do it again. Inverse cosine of -0.5. Now that is 120 degrees. That does look right. And 120 degrees is E. Just shows you what missing a negative can do. Okay. Where are we off to now?
Did you do a 33 on section 2?
Yes. I'm trying to find a quick way. Is there a shortcut way of not having to scroll through every single page on this? Has anybody figured out how Canvas and
Well,
PDS work? I
you
should be
can-
catch that and drag it, but not in my mouse I can't.
Well, if you open it up into a real PDF, just click on it. You can scroll faster through it. There's also a
Okay.
function you can do Control F, and you can just
Right, so
type it in.
practice final. Here we go. So what do you say I do? Click here?
Open it up in its own page, not in Canvas.
Well, the only way I could do that, it would be, oh, that's too much work.
If you just click on it, it should just open it up for you.
By left or right click.
If you there should be a button that gives you options. Just preview it or download it. If you download it,
Yeah.
then it should open it in its own page.
Well, I can download it, which is a pain in the butt, which I don't want to do. I'll just do it this way. Right, you went and said, what was the other button you said? Control F?
Yeah. And it should give you a search option. You can type in 31.
Mm, I guess that's possible. There. That sounds like a good plan. Unfortunately, that's the solution, which is, God, life is fun. You know, in 100 years from now, this won't matter. Nothing that I'm doing right now is going to be a big deal.
It will matter.
It will matter. There we go. Okay, so now that was the question that was done earlier, where there's a typo in it. So if it's just a typo that's thrown you, I can fix that right now. The original question.
It should be
Hi.
problem 33.
Oh, 33. Oh, that's better. Okay. We're being asked to do contour maps of those guys, right? Little picture here. And it's not hard to do. I could do it by hand. I think I've got some software. Let's see if we can find it. Okay. I'll go Desmos, contour. Yeah, contour map, Bosworth plot, bump. I'm going to leave this one. Okay, that'll work. Right, so we have a function 12 over x minus y. A contour map is basically like a cross section in a 3D map. If you've ever done orienteering, right? Points of equal height are joined together to make a curve. And we call them contour maps. So I'm going to now show you how to do it using the software. Are you looking at Desmos with a little interesting picture? Right, so I should be able to just rub this out and put in 12 divided by x take away y. And what's wrong? Oh, equals it. There we go. Now, if I zoom back, there you go. It's made up of a whole series of parallel lines. Now, I'm just going to choose a selection of these lines. So, make sure I don't rub out too many. There we go. The one, 3. There we go. So I'm using -3, -2, -1, 0, 1, and 2. And you can see it's basically a whole set of lines. And that's the simplest way to do it. Another way would be to do it by hand.
I have a question.
Yes.
So on that problem, it says for k equal to 1, 2, 3, and 4.
Right. So in that case, I would just go 1, 2, 3, 4 and get those.
All right.
So let's do k equals 1. Basically, you make the function a height of 1. If you cross multiply it, and then if you add a y and take away a 12, you get that. So that would be my first line. Now, if you do a height of 2, you get 12 equals 2x, take away 2y. You get 2y equals 2x, take away 12. And then you get 1, it's x equals 6. So, can you imagine I draw a line, slope of 1 passes through the y-axis at negative 12. The next one is going to be passing through at negative 6 and slope of 1. So that would be k equals 1. That would be k equals 2. If you make this 3, you get 12 over x minus y equals 3. That gets you 3x, take away 3y is 12. Oh, that gets you 3x, take away 12 equals 3y. That gets you x minus 4 equals y. So you put a dot there, you do negative 4. Pretend I can draw straight lines. You get that. And then you do the fourth one. And what happens if you do the fourth one? Nothing particularly interesting. And you just end up with another line that looks like that. And that would be the contour map of that particular one. Show you a different one. Suppose I gave you a pretty balanced one, that guy, and I told you to do it for k equals 0, 1, and 2, say 4. K equals 0, you are looking at that, which isn't even a function. The only value of x and y where that's true is the origin. You then make it equals 1, which would be a circle, radius 1. You then make it 2, which would be a circle, the square root of 2, which is about 1.4. So can we pretend that 1.4 is about here? And then the last one is 4. So x squared plus y squared equals 4 is a circle radius 2. And it looks something like that. It looks like a bullseye to me. Can you imagine concentric circles? Now, if you wanted to visualize what that would be, have you noticed it's circular and on the outside it's high, and as you move towards the center it gets low? And it's not, although it might look like it, equally spaced ones. It's a little bit denser at one side than the other. So can you imagine it might look something like this, with the z-axis shooting up the way. So what this allows us to do is to visualize what a three-dimensional surface might look like. It's helpful to be able to do that, but don't we have a program called GeoBra that will do the whole thing for us now? We can see what it looks like without needing to resort to this. But this is how you used to do it before computer graphics, you know, and computer software were around. Right, you had to have a way of trying to visualize it. And it has other uses, but that's one of its uses. We still use it today, because I know that some of my students have said that you have to be able to read a map in the military, at least some of you. You don't always get GPS, right? You could be someplace where the satellites are shot to bits and you can't do it, right? So all you're going to have is a piece of paper. Those maps are contour maps, right? The maps they use, right? They join points of equal height, which is what this is. And if you do enough of them, you can look at one of those maps and you can visualize what the terrain should look like. Oh, there should be a mountain over there, and the one on the left should be steep, and the one on the right is not as tall and much more curved. You know, you can get visualize it so you can get an idea of where you are, right? And that's obviously what one of the reasons you have maps. Gives you an idea of where you are because you want to know that, and you want to know where you want to go. And so you can plan your route accordingly. Okay, where are we off to now? Hi, Kira. How's things?
Good, good. Sorry, I'm late.
No, you're not late. This is a drop-in day. You can drop out and drop in when you feel like it. So, since you've just arrived, do you have a question?
Not at the moment, but
That's okay. You might. Okay. Open to anybody then. What's the next question?
Could you try 35 on section 2 as well?
35, coming up. Make sure it's the right one. We get a function, multivariable, x, y, e to the y, and we're being asked to find these two partial derivatives and show that they're equal. So the fact I'm asking you to prove that they're equal means you really do have to do both. In a normal question, wouldn't you just do that one and use Colorow's theorem and say that's the same, right? But in this question, we're being asked to prove it. So let's get this one first. The partial derivative with respect to x of this function is just y e to the y. X is a variable, that's a number, right? 5x gets you 5, it's the analogy. Now, if you want to do the second derivative with respect to y, aren't you essentially just going to do a product rule? Because both terms have a y in it, it's a product rule. So we are going to get 1 times e to the y plus y times e to the y. And it's very like an earlier question I saw. But if you pull out the common factor of e to the y, you get that. Let's go for this one. To differentiate this guy with respect to y, you're going to also do a product rule. This piece here, I'm going to call f. And this piece here, I'm going to call it g. So it's f dash g plus f of g dashed. If you differentiate x, y with respect to x, if you differentiate x, y with respect to y, you get x, and then leave that guy alone. Plus, leave this guy alone, and differentiate e to the y with respect to y, gets you that. And if you pull out x and e to the y as a common factor, you get that. And that's the first part. Now you differentiate with respect to x, and essentially all of that counts as a constant. And would you agree I've proved that they're both the same? And that's what the question, that's part A was about. You want me to do part B?
I think it's fine. Thank you.
Okay. Anybody for our next question? God, it's 5:55 already. Time shoots by. Anyway, come on. I'll try and get as much done as I can. Next question. Or have we finished? I guess that's also a possibility.
Can you write a list of the formulas we're going to need and post it on the line for us?
Not enough time, sorry. It's not hard to find formulas. I mean, just do a sensible search, something like Calc 3 formula, and see what comes up. Saves you having to write them all down. Sometimes when you do that, you get formula that you'll say to yourself, I don't know that one. I've never seen that one. Well, that's okay, because that just means it's, you know,
Well,
something we don't do, so you don't need to worry about it.
because a lot of university and stuff, they have semesters, so the Calc 1 and 2 for us is Calc 1
Yeah.
for them.
Yeah,
So Calc
exactly.
3 for them would be Calc 4 for us.
Well, I think the way it goes is 1, 2 is their Calc 1 and 3, 4 is their Calc 2-ish. So if you get a university one, you might end up getting a lot of formulas from Calc 4, which you would totally ignore because it's nothing you need to know right now. But I just don't have the time right now. My priorities are right now is doing what I'm doing right now with you lot and getting ready for the final. So, any other questions? I mean, your time is valuable. I don't want you just staring here looking at me.
I was wondering, do we have class
Mhm.
tomorrow?
No, there are no more classes for you until the day of your final, which I'm now going to find my piece of paper in case I lose it. And for our class, it's on Wednesday.
At 5 to
So
8.
exactly 5 till 8.
Oh,
Now,
no. So there's no questioning class like this tomorrow, right?
correct. There's nothing tomorrow. I'm going to be in exam mode because I'll be taking, all this week I'll be supervising exams or grading exams that have been already completed. So I won't be available for any stuff.
Do you
What-
open your office hour tomorrow, or you're not
No.
going to be available? No.
No more officers. So, I mean, you could shoot me an email and hope that I see it relatively quickly, and I'll try and reply to them as soon as I can. I still figure out how to fix your report because evidently I didn't copy a cell that changed the grade for a 2.0 to a 3.0 to a 4.0. But
You
I
going to fix
don't
that?
know. I'm trying to fix it. I went in to fix it, and of course, the weird day that today has been, it stopped me doing it. Actually, I normally do it from my office computer in my home office, and it works fine. But today it decided to die. It just wouldn't work. So my backup plan was to do all the files and then upload them virtually into my office in the college, and then connect them, virtually to that, and then send them that way. And I did get to send them, but now it doesn't allow me to change them, which means I'm going to have to figure out how to do that. So it's just the fun of the job. Although I don't have enough hair to pull out, so I'm not allowed to do that. Got to be quite protective of what little hair I've got.
Professor, which platform were those reports sent on? Because I didn't receive one.
I sent them to your email. So let me tell you what email I used. I won't give the whole email, but I will tell you the one I used. And here's 163. Justin, you were the one that was talking there. Was it?
Yes, sir.
So it was sent to your student email.
Yeah,
Olympic
I don't
College
see
one.
it in my inbox, but I'll
Play
maybe
about and find it.
yeah, I'll play about and find it. Maybe it's in the
Right.
spam folder or something. All right,
Okay.
thank you.
Yeah, if you don't get it, if you shoot me an email with a different email address, like your Yahoo email address or something like that, I can resend it. Well, I used to be able to resend it really easily. Who knows today what that will end up looking like. But if nothing else, I can copy and paste it and send it into Canvas. It won't look pretty, but the numbers will be there. So I'll get a report to you some way or other, if I possibly can.
Thank you very much. Yeah, it's probably in my email. I just yeah, I'll look through it.
Okay. Any other questions?
A question.
topic. Mhm.
I was wondering if you could like do a quick overview of the second half of this course of the vectors and like a quick overview, if that's possible.
Well, I can try. Hold on that thought. Let's see what we've got here. Right, if I go to the syllabus, we have one. Not in 15 minutes, I can't.
Oh,
I'll
that's
show
all
you
right.
what I can show you what's there, and I can maybe do an overview of a subset of that. Right. So we have 3D coordinate system, then the beginnings of vectors, dot and cross products, equations of lines and planes, vector functions, derivatives of vector functions, arc length and curvature formula, motions, multivariate, and then I guess the rest doesn't matter. Probably multivariate doesn't even matter. So each one of them has got a lot of stuff in it. So I won't even call it an overview if I tried to. I would just be telling you the headlines. You can read that anywhere.
No, that's
So
all right.
any one of them you want, anything you'd like. One of those sections I might be able to do in the time we've got. If you're not, if it's not,
I'm thinking of one.
okay,
What about, can we do motion in space?
sure. Just writing down headline, motion in space. Right, what we are looking at is essentially space curves, which are a fancy name that we give to an object moving in 3D space. So a space curve, if you imagine this is our X, this is our Y, and this is our Z. Space curve is like the path that a jet might take in 3D space. We very often call it R of T. It's sometimes called its position function. And it has an orientation because you travel, in this case, you're traveling that way. Now, there's a vector called v of t. It is called the velocity vector. And the velocity vector essentially tells you at any given instant in time, the general direction that you would be traveling. And for instance, if I picked this one, the velocity vector might be that guy. Whereas if I chose here, the velocity vector would be that guy. Can you see as you travel in 3D space, at any given point, where am I pointing is essentially your velocity vector. And the length of that vector, we call length of vectors magnitude, describe it like that. That is a scalar, that means it's a number. And that tells us the speed of whatever the object is. So for instance, suppose I had a space curve, a roller coaster perhaps, and it was t squared sine t e to the t. Then if you find its first derivative, you get 2t cosine t e to the t. And the first derivative is how you calculate the velocity vector. Now, if you want to know what's the speed at any given point t, then the speed is the magnitude of the velocity vector, or if you prefer, the magnitude of the first derivative, because they're the same thing. Now, if you take this guy and you find its magnitude, it's the first guy squared plus the second guy squared plus the third guy squared. In this case, that would be 4t squared plus a cosine squared plus an e to the 2t. Now, if you wanted to know the velocity or the speed as this object travels its journey, let's say at a specific time, like t equals 0. So that would be just as it started the journey, right? Then the velocity vector at 0 would be 2 lots of 0, cosine of 0, e to the 0. And if I wanted to know what speed was it going, it would be the square root of, well, nothing, plus 1 squared, plus e to the nothing, which is just 1. And so it would be going square root of 2, let's say meters per second, in that direction. Now, the next thing that you would be interested in calculating probably when you're talking about something moving in space would be its acceleration vector. The acceleration vector is very closely related to Calc 1. Remember, the first derivative is velocity, second derivative is acceleration. And this is also true. If you want to calculate the acceleration vector, you would find the second derivative of the position vector or the first derivative of the velocity. They are the same thing, right? So the rate of change of velocity is acceleration. So in our case, the acceleration vector is differentiate this guy, you get 2. Differentiate this guy, you get negative sine t. And differentiate this guy, you get e to the t. And if you wanted to know what the acceleration at the beginning, 2 is fixed. Sine of 0 is 0. E to the 0 is 1. We don't bother to find the magnitude of the acceleration vector. It may well have a meaning, but we don't give it a name, that at least none that I know of. So far, so good. Now you can undo that process. So this is a different object moving. So you may have the acceleration is 6t e to the t 2 cosine t. And you are told that the velocity vector at 0 is 1, 1, 1, and that the position at 0 was 0, 1, negative 1, right? And with this acceleration and these two boundary conditions, we can work backwards and create the entire space curve. So if you start with acceleration and you want to find the velocity function, don't you integrate, right? The opposite of differentiation. And if you want to integrate a vector, don't you simply just integrate each piece? So you integrate 6t and you'll get 3t squared plus an average constant, which I'll call C1. If you integrate e to the t, you get e to the t plus an average constant C2. And if you integrate 2 cosines, you will get 2 sines plus an average constant C3. And we now have a generalized version of what the velocity function would look like. Now I'll use this boundary condition that the velocity at 0 is 1, 1, 1. So the velocity at 0 equals 3 lots of nothing, still nothing, so you get C1. E to the nothing is 1, so you get 1 plus C2. And the sine of nothing is nothing, so you get C3. And we know, because we're told, that it's equal to 1, 1, 1. And if you match them up, C1 is 1, C2 is 0, because 1 plus 0 gets you 1, and C3 is 1. That means we now have the full version of the velocity vector. It's 3t squared plus 1, e to the t plus 0, and 2 sine t plus 1. So far, so good. Now, to work backwards one more time. So if you take the velocity vector, which is what I've just written, and you work backwards, you will then get the position vector, which is the integral of that guy. And if you want to integrate a vector function, you integrate each of its pieces. 3t squared, t cubed, 1 gets you t, plus an arbitrary constant c1. E to the t is e to t, plus an arbitrary constant c2. If you differentiate 2 sine, you get -2 cosines. You integrate a 1, you get a t, plus c3. We have the generalized version of the position function. We'll then use the position at 0 equals this to find the c1 and so forth. So the position function at 0 is nothing cubed plus nothing plus c1 gets you c1. E to the 0 gets you 1 plus c2. Cosine of 0 is 1, so that's -2 plus nothing, so it's -2 plus c3. And that is going to be 0, 1, -1. And let's watch them then. C1 is 0. Well, that's easy. C1 is 0. 1 plus C2, just that guy, is 1. That means C2 is 0. -2 plus C3 is -1. Add 2 to both sides, and you have now got C3. So to complete R of t, the position function, t cubed plus t plus nothing, so we're finished. Middle one, e to the t plus nothing, so we're finished. The last one, -2 cosine t plus a t plus a 1. We now know everything you need to know about this moving object, right? There's nothing unknown. I can plug in 22 and I'll tell you where it will be at 22 second mark. Although this is a vector, it's got a special property. It's called the position vector, which means that the numbers that you get here are the vector it makes from the origin. So isn't that just the same thing as telling you the coordinates? So that's a special, interesting vector because it basically is our way of doing coordinates. How you give the answer as a coordinate, at least. You give its position vector. Are we good? Russell is disappearing on us.
Could we look at putting an equation into parametric form?
Sure. Try to think of an example of the situation. Are you talking about creating the equation of a straight line in parametric form, or what? What kind of situation are you talking about? Have you got an idea?
I see one on the practice final.
Oh, perfect. What
Number
does
10.
it look like? Number 10. That's the easiest way for me to do that. Back.
And it's a multiple choice.
Okay, thank you. That helps. So we just have, okay. Now, what you've got here is a curve. Not that you need to know it, it's actually hyperbola. And there are 5 possible, but only one works, parametric equations. And I'm not picking this for any particular reason, except it was the first one. And there's 5 altogether, right? There's a B, there's a C, there's a D, and there's a E. So only one of them work. So what you're going to do is you're going to pick one and see if it works. And if it does, stop looking. You've found the right answer. And if it doesn't, throw it away and move on to the next one. Right. So I'm going to start with this one and see what we get. X squared, if you square this guy, you get 4 secant t's over 4. And if you square this guy, you get take away 9 tan squared t over 9. And if this works, that should equal 1. Well, that guy gets me secant squared t, and this guy gets me negative tan squared t. That should equal 1, right? So far, so good. Is that true? If it is, we're finished. Right, let's suppose we don't know. 1 over cos squared, take away sine squared t over cos squared t, becomes 1 minus sine squared t over cos squared t. 1 minus sine squared can be written as cos squared. And it works, so stop looking. Now, you know Murphy's Law, don't you? That if you pick randomly, won't the last one be the correct answer? So if you pick C, it's going to be B, right? If you pick D, it's going to be A. If you pick A, it's going to be D. I kind of knew that one worked, but you know, I could have picked one that didn't work. So question E, for instance, is 2 sine t, and that's X, and Y is negative 3 cosine t. Now, since I don't have room, I'm going to stuff the working in here. That guy gets you 4 sine squared t over 4. This one gets you take away negative 3 cosine t squared over 9. Now I'm writing this one down, and I didn't do that one because this one becomes sine squared t. Isn't a negative 3 times another negative 3 plus 9? And 9 cos squares over 9 gets you that guy. And hopefully you would look and say, nope, that one ain't one. Right? And so off my list. All the others don't work for various other reasons. How we doing? I think we get time for one last question. So who's got it?
Question. So the orientation of the test is not matter, right? Like if I'm going to do like question 1 and then skip question 3 and then do question 4 instead, that is fine,
Don't
right?
mind. Don't mind. Multiple choice, just write down the 10 numbers and leave them blank and do them in any order you like. That's very easy. If you're doing section 2, I have no problems with you doing that. Only suggestion I would have is it helps if you do them in separate pieces of paper and then you can put them in order when you're finished. That just saves me, because I've got 100+ exams to grade. And the last thing I need to do is spend 5 minutes just figuring out where question 3 is. Or did they even do question 3, which means I will scan through a second time just in case I missed it. So if it's in order, I'll see 1, 2, couldn't do 3, 4, 5, 6, and it makes it much easier for me. So for my benefit, it would be helpful to do them in any order you like, but to combine them in order when you photocopy, when you take pictures.
Okay. What about the multiple choice question? Do I need to show my work or just
No,
say?
don't care. You might just get lucky. Pick C if you don't know. That's a good way of not wasting time, right? If you don't know an answer, pick C or B or whatever letter you like and move on. If you've got time at the end, you know, go back and have another look. Maybe it'll come to you then. But the worst thing you can do is leave it blank, because then it has to be wrong. So you might as well pick something. That would be my suggestion at least. 。 Well, I guess that is it then. Have a great, but not too great tomorrow. I will, as soon as we've finished, I'm going to get some food, or else I'll start thinking about my dogs looking interesting. And once I've done that, I will then try and figure out why, or fix the report and send you out a new one. If I can't, because it could happen, I know what it's like. You know, you need 750 points to get a 2.0. You need 850 points in total to get a 3.0. And you need 950 points to get a 4.0. So if you take your percentage and multiply it by 700, that's how many points you've got right now. And then you can figure out what I just said from that. So if your grade right now is 90%, right? 90% of 700 is 630 points. That's how many points you've got. So let's show you what that would look like. So you've got 90%, right, of the 700 points. So that ends up being 630. A 2.0 is 750. Quick subtraction. That means you would need 120 in the final out of 300 to pass. If you're more interested in a 3.0, you need 850. That would be 220 points. And if you wanted 4.0, you would need to get 950 points, which for this person is not going to happen.
You give credit, right, on the exams?
You'll get partial credit on section 2, not extra credit, but partial credit. So if the process is correct and you can show me clearly the process, it's much better for you in the long term, even if it means you have to write down more stuff, because you may make a simple plus disappears, right? It should be negative and you've got a plus, or some really fiddly thing, but the process is 90% right, then you're going to get 90% of the points. I can't tell that if you don't show me working. In fact, in some questions, if you don't show me working, I'm giving you 0 points, because it could be you didn't do any math at all. I mean, it could be just an indication that you found a way of cheating, and you'll get 0. You'll get 0 for cheating. Or you used GeoBra and just looked at the picture. Now, since there's no working for multiple choice, you don't cheat, but in multiple choice, can you take as many shortcuts and tricks of the trade that you can, including looking it up in GeoBra and seeing what it says like? That would be a valid way, maybe solving a question of that. But not in section 2. Section 2, I want to see how you do things.
I had a question. So are we allowed to use GeoBra? Because it's just like
yes. I will have, when you come in for the day of the final, everything in WebAssign will have disappeared. Everything in Canvas except one module will exist. And anything that I think you're allowed to use, I put in that module. So I'll put GeoBra in there and Desmos in there. And if I can remember to, and I need you to, I'll put in that, you know, the
answer.
The plot thing, right? The equal height plot, which my brain's just totally left me, but I'm in a long day today.
Question: if the question involved graphings, and if I graph on GeoBra and I just
there won't be any working associated with that.
So should I just draw it in my paper, right?
Probably not.
So what should I do then?
Well, it depends what the question says. So, I mean, if the question said, I'm trying to think of one where you would do it. I can't think of a question where I'd ask you to draw it. Now, you might use GeoBra your own to check things, are fine. Desmos comes to mind. You know, when you try and solve some equations, you put it into Desmos because it's too difficult to do algebraically, but you can put it in Desmos and find out where it crosses x-axis, right? Things like that, like we did today for the R3 function, right? I can imagine you doing that, but you won't show me the picture. Won't you just say it was 0.003 and whatever it was? So that that I wouldn't expect a picture for. You might, but this isn't to show me, but do you know if you do a T3 of X, can you put the original function into Desmos and the T3 of X into Desmos? And if they match really well, isn't that a good way of checking you've done it right? And if the curves don't look anything like each other, isn't that, oh, okay, maybe I should check something. So you could use it for checking as well. But I don't expect you to be using it much apart from those things.
Question, can the finals be doing on any paper? Because I have like a really big pile of graph paper and no ordinary papers.
I don't mind as long as I can see it. So you might want to make sure that the pen is nice and thick if you're using a pen. Try not to write. No, it doesn't work on a pen. But I've seen people use pencils where they're trying to make me go blind by writing it so faint I have to look for shadows to even tell what you've written. So try not to write. Make it easy for me, right? I'm getting old. I need to see. So make it nice and bold.
I had a question.
Mm-hmm.
Why did you switch paper?
I've ran out.
All right.
Not a very interesting answer. A bit like Viet. I mean, I ran out of line paper the class before this class, class 3. Last of my line paper died on me. And I haven't got any handy. So
Alright.
that's the only reason. As today's been one of those days, so why shouldn't I run out of paper today, right? I mean, it's just one of those things.
I was wondering if the centering of the camera looked odd because you were using different paper.
No, it's square paper. I mean, if you look on the other side, it's much more square. Oh, there we go. You see it? I'm just using the faint side because I think the squares distract people. That's all I was doing.
All right.
You said there's an issue with the new report. Is the percentage on it right? But there's just
Everything is correct. The only thing that I've been told is the number of points that you need to get these grades isn't there, or it's the wrong number, or it's the same number. I can't remember what the error was.
Okay.
The number's not there.
Right, so it's just totally blank.